Despite the incredible advances in engine technology, twin-engine aircraft still faced a major obstacle: aviation regulations. For many years, regulators were concerned about the possibility of an engine failure during long flights over oceans, deserts, or other remote regions. As a result, twin-engine aircraft were required to remain within a certain distance of a suitable diversion airport. This limitation made it difficult for twin-engine aircraft to operate many long-haul routes. Airlines continued to rely on 3- and 4-engine aircraft for flights that crossed vast oceans and remote areas. However, as modern jet engines proved themselves to be exceptionally reliable, regulators began to reconsider these restrictions. This led to the introduction of ETOPS, which stands for Extended Range Twin Engine Operations Performance Standards. ETOPS allows twin-engine aircraft to fly routes that take them farther away from diversion airports than previously permitted. As engine reliability improved, ETOPS approvals expanded. Aircraft were first allowed to fly 120 minutes from a diversion airport, then 180 minutes, and eventually even farther. These changes transformed commercial aviation. Suddenly, twin-engine aircraft could fly many of the same long-haul routes that had once required 4 engines. What had once been considered impossible was now becoming routine. Twin-engine aircraft were no longer limited to short and medium-haul flights. They were beginning to challenge the dominance of 4-engine giants. And airlines quickly realized that this new capability came with significant economic advantages. Once ETOPS regulations allowed twin-engine aircraft to operate long-haul routes, airlines began to realize something important. These aircraft could perform many of the same missions as 4-engine jets, but at a much lower cost. Fuel is one of the largest expenses for any airline. A twin-engine aircraft generally burns less fuel than a comparable 4-engine aircraft, allowing airlines to save millions of dollars over the life of an aircraft. Maintenance costs were another major factor. Every engine requires inspections, repairs, spare parts, and regular servicing. By operating 2 engines instead of 4, airlines could significantly reduce maintenance expenses. Twin-engine aircraft were also lighter. Less weight meant better fuel efficiency and improved overall economics. Airlines could carry passengers and cargo more profitably while keeping operating costs under control. As competition in the airline industry increased, these savings became impossible to ignore. Airlines were constantly searching for ways to reduce costs while maintaining safety and reliability. Modern twin-engine aircraft offered exactly that combination. They were efficient, reliable, and capable of flying the same long-haul routes that had once required 4 engines. As a result, airlines around the world began replacing older 4-engine aircraft with newer twin-engine designs. What started as a technological improvement soon became a major shift in the economics of commercial aviation. The era of the twin-engine airliner had truly begun. The success of twin-engine aircraft was not driven by a single advantage. Instead, it was the result of several benefits that together transformed the economics of commercial aviation. The most obvious advantage is fuel efficiency. Modern twin-engine aircraft consume significantly less fuel than comparable 4-engine aircraft. Over thousands of flights each year, these savings can amount to millions of dollars for airlines. Another major advantage is lower maintenance costs. With only 2 engines to inspect, repair, and maintain, airlines spend less money on servicing and spare parts. Aircraft can also spend more time flying and less time in maintenance facilities. Twin-engine aircraft are generally lighter than their 4-engine counterparts. A lighter aircraft requires less energy to fly, further improving efficiency and reducing operating costs. Modern engines are also remarkably reliable. Decades of technological improvements have made engine failures extremely rare, giving airlines confidence to operate twin-engine aircraft on some of the world's longest routes. Environmental concerns have become increasingly important as well. Because twin-engine aircraft burn less fuel, they produce fewer emissions than older 4-engine designs. This helps airlines reduce their environmental impact while meeting stricter regulations. Finally, twin-engine aircraft provide airlines with greater flexibility. Their lower operating costs make it easier to serve routes that might not be profitable with larger, less efficient aircraft. Together, these advantages have made twin-engine aircraft the preferred choice for airlines across the globe, helping them carry more passengers more efficiently than ever before. Now we will see how twin-engine took over the skies in the next video, which is going to release on the 4th of June 2026.